We've been talking a bit about solving systems of equations. We've been talking about 3 different methods. We've been talking about graphing, substitution, and elimination. Now, this is something that's going to be a little bit scary for some of you guys, but you guys are going to have to make some independent choices in these next few days. What that means is I'm not going to be able to tell you, hey, solve the problem this way. Here's step 1, here's step 2, here's step 3, here's step 4. You guys, again, 8th grade, going into 9th grade, going into high school, are going to have to try and figure out some ways to solve some of these problems by yourselves. And I was talking to a friend of mine, and she's going back to school, and she's taking a math class, and she's doing proportions, and she just could not wrap her head around that there's not a 5-step way to do a problem, that she would have to figure out how to set up the proportions, that there's more than one way that will give you the correct answer. So what I really want to talk about today is essentially these 2 methods, substitution and elimination, and how we're going to be able to do problems like this, but sometimes it's not going to be so cut and clear as to which method you should use. Now, it's good news for you guys because if there's one of these methods you're better at, you can lean towards that method. So if you're very good at substitution, you can pretty much do all these problems in substitution. If you're better at elimination, it might be that you can turn all these problems into elimination. And the cool part is that you can play to your strengths, and that's something that doesn't happen up to this point in math. And this is really like whatever works for you, you're going to do. Now, some things are going to lend themselves to one, some things are going to lend themselves to the other, and some of them is going to be such a hassle to get something from a substitution form into an elimination form that it might not be worth it. You're going to create so much extra work for yourself. You're going to create fractions. You're going to put negative numbers where there weren't negative numbers, and all those ugly things that we don't like to deal with, okay? So, look, really, when is a good idea to use substitution? Well, when you have a variable isolated, right? So here, I have y is equal to 3x minus 2, right? So I can just plug 3x minus 2 right in here. That's pretty straightforward, right? Now, if I wanted to use elimination for this, I could, but again, is it worth the trouble? Here, substitution is not a good idea, right? Because I don't have any variables that are isolated, nor are any of my variables having a coefficient of 1, so it wouldn't even be easy to move them around. So I'm going to go through these first 2 problems showing you both ways and how one will be exceptionally easier for each one of these choices. Like I said, it's what you're working with, okay? What you prefer. And some of them will be obvious and some of them will not, okay? General rules of thumb, okay? If both are in y equals mx plus b form, okay? If both of them are in slope-intercept form, any of your 3 methods will work, okay? Graphing, great, right? The only drawbacks to graphing is if you have fractional answers, right? Substitution, sure. If they're both equal to y, they're both equal to each other, so they just set them equal to each other. And believe it or not, we can use elimination. We use elimination more with standard form, but think about it. If I had y is equal to mx plus b, and another y is equal to mx plus b, again, everything is set up the way it's supposed to be. You can stack them and eliminate them, okay? If one is in slope-intercept form, and one is in standard form, you really want to do substitution, right? Because why? Because the y is isolated, and you can plug the y right in for there, okay? Now, that's not to say that you can't. Like, if you had some nice coefficients, some easy coefficients to work with, it might not be the worst idea to do a little bit of changing. But essentially, if they're both in slope-intercept form, you want to graph, you want to substitute, you want to eliminate, that's your option. Once you have 1 and 1, you kind of change your options, okay? And your other option is if they're both in standard form, ax plus by is equal to c, you're going to use elimination. Okay, right? When that's most of the examples we looked at the other day. Okay, so you're going to stack them up and you're going to work with them. Now there are some other forms like just random x equals forms and things like that, and we'll take a look at those today. Generally speaking, though, if you have an x equals form, it's the same thing as y equals form, right? Where you have a variable isolated. Okay, so let's take a look. We're going to take a look at these two problems. I'm going to show you how to do them both different ways. Okay, so this first problem, this lends itself to substitution. Okay, this lends itself to saying 3x minus 2. Well, y is equal to 3x minus 2. So everywhere I see a y, I'm going to replace it with 3x minus 2, and then I'm going to finish writing this equation. Okay, so all I did was rewrite this equation, except instead of writing y, I wrote what y is equal to. Okay, and then you can go ahead and you can solve. You say 3x, right? I'm going to distribute this in negative 2. Negative 2 times 3x is going to be negative 6x. Negative 2 times negative 2. Positive 4, and that's an equal negative 8, right? That was distribute. Then we said our next step was to simplify. 3x minus 6x, negative 3x. Good. And now let's balance, right? We're going to subtract 4 from both sides. Negative 3x equals negative 12. We'll divide by negative 3. We'll find out that x is equal to 4. To get y, we're going to plug right back in here. Y is equal to 3 times 4 minus 2, right? Everywhere I see it. Now I could have plugged back into this one, but why? Why? This one's tailor-made. Y is by itself, right? Y is equal to 3 times 4 is 12, and 12 minus 2 is 10. We said it's a good idea to check your answers, right? So we're going to plug it into this one. 3 times what we said x was 4, minus 2 times when we said y was 10. 3 times 4 is 12. Negative 2 times 10 is negative 20. And yes, negative 12 minus 20 is equal to negative 8. Okay? So again, substitute and solve. Plug it into the other equation. Check your answer. All right. Now, what if we wanted to put this into elimination form? Well, for it to be an elimination form, we pretty much want it to look like this one over here, right? Where everything x's are stacked up, y's are stacked up, and numbers are stacked up. For this one, and again, the more of these you do, the more familiar you get with it. This one is really not such a bad idea, right? If I took y is equal to negative 3, is equal to, oops, hold on. Y is equal to 3x minus 2, and I went ahead and I subtracted 3x from both sides, I would get negative 3x plus y is equal to negative 2, right? So that was actually pretty easy to put into standard form. And in fact, if we were to kind of look at this and we were to kind of stack these up, oh, that actually works out really nicely, right? If I wanted to subtract these two equations. So if you were so inclined, okay, again, what happens when you eliminate 3x minus 3x, if I just go ahead and add these together as they are, that's 0. This becomes y, and this becomes negative 10, right? I'm sorry, negative y becomes negative 10, right? Good. So, and then again, we're going to divide by negative 1, and actually getting y to be equal to 10 was pretty straightforward. Now, getting x out of it is going to be a little bit more difficult, right? We're going to have to say y is equal to 3 times 10 minus 2, and 3 times, oops, oh, I'm sorry, I did what I didn't want to do, I'm sorry. Plugging in for x, plugging in for y, sorry, plugging in for y, again, 10 is equal to 3x minus 2. I'm going to add 2 to both sides. I plugged in for y. I'll say 3x is equal to 12. And we'll find out that x is equal to 4. So again, you get to play on what you want. Now, the obvious answer for this one is say, hey, substitution, put this in for y. It was a much easier, more straightforward route. But again, if you find yourself being much better at elimination method, then you can go ahead and you can do it with elimination method. Okay, it's your call, and that's kind of the good part about this is you get to play to your own strengths. Okay, now this one right here, this is made for you to do elimination, right? We're going to add these two things together. I have the positive and negative version of the same number. 2x and 4x is 6x, negative 3 and positive 3 is 0, and 7 and 5 makes 12. I'm going to divide by 6. X is equal to 2. That was very straightforward, right? Now, if I want to find y, I'm going to plug it back in here. 4 times 2 plus 3y is equal to 5. 4 times 2 is 8. And subtract 8 from either side. 3y is equal to negative 3. Y is equal to negative 1. Very straightforward, right? Very, very straightforward, okay? And if we want to, we can check it in the other one, right? We'll say 2 times 2 minus 3 times negative 1 is equal to 7. 2 times 2 is 4. Negative 3 times negative 1, positive 3. 4 plus 3 is 7. So again, very straightforward. We eliminated, we solved for x, we plugged in, we solved for y, we checked our answer. Very, very straightforward. Now, this one, if we wanted to put this in slope-intercept form, okay, and we wanted to substitute into the other equation, let's take a look at the mess that it's going to create, okay? Let's say we took either, and neither one of these is going to work out well. So say I wanted to take 4x plus 3y is equal to 5. Now I want to put that in slope-intercept form. I'm going to start by subtracting 4x from either side, so no problem there, right? 3y is equal to negative 4x plus 5, and then I'm going to divide by 3. Okay, so y is equal to negative 4/3 x plus 5/3. That is what you have to plug into the other equation. Now, it wouldn't be the end of the world, and you would get the right answer. But is it this? If this is what you want to work with, then I don't know what kind of math teachers you have had, but this is not what you want to work. You don't want to work with these fractions if you don't have to. Now, it will work if you plug it back in. It will actually cancel out fairly easily because there's a 3 there. But again, to what end? You're going to make so much more work for yourself to create this form. You're going to create so many more opportunities for mistakes that it probably isn't a good idea, okay? So if I had to make a call, okay, and I said, hey, what's the better method for solving this first one? Definitely substitution. And for this one, definitely elimination. Okay? Right? Again, substitution because all I have to do is plug in for y. Elimination because everything is stacked nice and neatly. Okay? So let's take a look at a few examples, and we'll pick the best route to kind of solve these, and you can take it from there. Okay. This one, since we have variables isolated, this is obviously what we want to do for substitution. Now here you actually have the option. I could plug in 3x minus 5 into this equation, or I could plug x into this equation. So let's go ahead and let's plug 3x minus 5 everywhere I see a y. So I'm going to say x is equal to 3x minus 5 minus 3. Okay? Since there's nothing to simplify in here and there's nothing to distribute, we can actually just drop those parentheses. Right? There's nothing to distribute, just 3 is subtracted, right? Let's simplify. I have x. Negative 5 minus 3 is going to be negative 8. Okay? Since I already have my numbers on this side, let's move the x's over here. Subtract 3x from both sides. 1 minus 3 is going to be negative 2. And the last step was divide both sides by negative 2. Turn my board sideways. Sorry. Okay? And what are we going to find out? X is equal to 4. Okay? I'm sorry, I'll try and keep it a little bit straighter. Okay? So now that I've got x, I need to get y. Okay? So let's plug it back into this first equation. So what are we going to say? Y is equal to 3x minus 5, and everywhere I see an x, I'm going to replace it with 4. 3 times 4 is 12. 12 minus 5 is going to be 7. Okay, so we think our answer is 4, 7. Let's plug that back into the other one just to make sure it works. So x was 4. Y was 7. And last I checked, yes, 7 minus 3 makes 4. So yes, that is a correct answer. Okay, good. So again, when we see these individual ones, go ahead and do substitution and solve. Okay. The second one made for elimination, right? Why? They're both in standard form, and in fact, even better, take a look. I have negative 2i and positive 2i, which makes this even easier. We don't even have to multiply by anything, okay? So let's go ahead. Let's add the two of these together. 5 and 2 makes 7. Negative 2 and positive 2 is 0. And 11 and 3 is 14. Let's divide by 7. X is equal to 2. So even if you're not good at elimination method, guys, that's a layup. You want to take that one, okay? Again, we can use either one of these equations to prove this is true. I'm going to say let's use the second one. Let's plug in 2 for x. So we're going to say 2 times 2 plus 2y is equal to 3. We get 4 plus 2y is equal to 3. Oh, we're going to get a fraction. We're going to subtract 4 from either side. What are we going to get? Sorry, I'm just going to continue this. 2y is equal to negative 1. Let's divide by 2. We'll find out that y is equal to negative 1/2. Okay. Now listen, especially for you guys at your level of math, whenever you get a fraction, let's double check that. Okay. So let's check it over here. Okay. Since I plugged into the second equation, I'm going to use the first equation. 5 times 2 minus 2 times negative 1/2 is equal to 11. 5 times 2 is 10. Negative 2 times negative 1/2 is going to be positive 1. And 10 plus 1 is equal to 11. So yeah, so it's okay. We got a fraction answer. Okay. You shouldn't be intimidated by those at this point. But again, like I said, always check. You can double check and make sure. Okay. So again, though, but long story short, the work aside, this one is made for elimination. Okay. Now, this last one is where you're going to get to choose your own adventure. Okay, so I'll solve this both ways, and I'll leave it up there for you guys. Okay, you don't have any variables isolated, right? So there's no y equals or x equals like there was in this problem, right? And in this one, neither one of them are in standard form. So here's where you get to choose your own. Now, for me, I'm using elimination. And why am I using elimination? Because I'm using substitution. I'm using substitution because I see that guy right there, okay? So to isolate any variable, and I can isolate x or I can isolate y, I would say the most straightforward way is literally I'm just going to add 5 to both sides on this one. And I'm going to find out that 3y plus 5 is equal to x. I have a variable isolated. Now, what I can do is I can plug in for x 3y plus 5 in this first equation. Okay. So again, was it fairly simple to isolate a variable? Yes, it was. If you wanted to, could you have, isolated y in this one? Yeah, but it would have been a little more difficult because you have a negative 1 in front of here. Since this x is just by itself, I would say that's your safest bet. Okay. So let's go ahead and I'll go through that one more time. I'm going to rewrite it over here. So what do we got? We've got 3x minus y is equal to 31. 3y is equal to x minus 5. Okay, so what am I going to do for the second one? I'm going to add 5 to both sides. I'll find out that x is equal to 3y plus 5. Don't freak out because it's on the right side. Remember, the equal sign is reversible. So what am I going to do? Everywhere I see an x in my first equation, I'm going to replace it with 3y plus 5. Okay, so all we did was substitute. Okay? Now it's pretty straightforward. Now we're going to go ahead and do what we were doing the other day. We're going to distribute, we're going to combine like terms, we're going to balance, and we're going to get our answer for y. All right? So let's start by distributing. 3 times 3 is 9. 3 times 5 is 15. Okay? I have 9 minus 1 is going to be 8y. So again, simplified. Okay? Now we want to balance by subtracting. 31 minus 15 is 16. Okay, and again, last step. Let's find y. Let's balance by dividing. Same thing we were doing the other day. Okay, so y is equal to 2. Now I got y, I want to use x. Now I can use either my two equations or I can use the new one I made, right? Because these two are actually the same equation. Use this one. Why? Because I'm going to plug in y and x is going to pop out. So I have 3y plus 5 is equal to x. 3 times 2 plus 5. 3 times 2 last I checked was 6. And 6 plus 5 is equal to 11. Okay? I'm sorry, so I'm going to continue this out somewhere. So x is equal to 11. Good? Now if we want to check that, you can plug it back into any of them. It doesn't matter. I'm going to plug it back into this first one. 3 times, we said x was 11, minus 2 is equal to 31. Well, 3 times 11 is 33. And 33 minus 2 is 31. Okay, so it works, okay? Let's make sure we write our answer somewhere nice and neat on here. So 11. Okay, so again, that's it using substitution. Again, kind of complicated problem, but nothing you can't handle, right? Let's talk about if we want to do elimination. If you want to do elimination, you got to get them both in the same form, okay? So again, for this one, probably really not too bad. Again, what do? What if I subtract x from both sides? This will become negative x plus 3y is equal to negative 5, right? These cross out, okay? And then I get 3x minus y is equal to 31. Negative x plus 3y is equal to negative 5. And again, now, is it pretty easy to solve? Sure, yeah. And multiply this top one by 3. So let's multiply the bottom one by 3. Okay, why? Well, then I'll have positive and negative 3x. So this top one's going to stay the same. And on the bottom, I'll have negative 3x plus 9y is equal to negative 15. Okay, now, if I go ahead and I add these together, what am I going to get? 8y is equal to 16, and it's all very familiar from there, right? Now, we had that in the other one, right? So again, you can pick your choice. I'm not going to go ahead and do this. I'll at least solve for y and show you that y is still 2. If you plug y back in, you're still going to get x to 11. You guys get to choose your own method. What I want you guys to do tonight is on the next page of this package. This is a great packet. The problem is, and we're going to be using it for a while. The problem is that when I downloaded it, and it's got word problems and all those other things we got to work on. It's all out of order. Okay. What I want you guys at least to do tonight is for the first 6, decide whether you would use substitution or elimination. Okay. Take a look at each one and say, hey, what would I use? You know, oh, my variables are isolated. I would use elimination. Oh, look, they're both in standard form. I would use elimination. You know, so again, decide what you want to use. Again, probably substitution, 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 elimination. Pick what you would want to use for the first 6. I know this is a lot of heavy stuff. And it's also much harder because we're not in a classroom right now, and I don't have the opportunity to see what you guys are doing. But take a look at the first 6. If you can start solving them, start solving them. If not, we'll start to go through kind of the best method. But at least what I want you guys to do tonight is decide whether you should use substitution or elimination. So, sorry, it was a long one today, but this is kind of, again, it's a big turning point for us. So, I'll talk to you guys soon. Please send questions if you have them. Thanks.